Now I'll explain the point of equation of continuity clearly with a diagrammatic approach. After this, I solve one numerical, then you have clarity on the concept of equation of continuity. Okay. Now here I define first one, equation of continuity. Point is equation of continuity. Equation of continuity. Okay now. It is the mathematical expression. It is the mathematical expression. It is the mathematical expression of the law of conservation of mass in a fluid dynamics. Because two categories are there. One is statics, another one dynamics. This concept is relevant to the fluid dynamics. Here I am showing the diagram now. This is the basic shape of the nature of the medium, where having the different cross sections, I named those two at the edges of this tube. What I am showing now, edges of those two. One is named as A1. It is at point A. Other one I named as, it is another edge. I named as it is B. That is nothing but A2. I tell you what are those A2, A1 and A2, A and B also. Now the amount of width, it is delta T. Now here also it is delta T. The speed is V1. Here the speed is V2. Okay now? Here I describe the terms now. A1 and A2 are two cross sections. A1 and A2 are two cross sections. Okay na? Containing A and B. Containing A and B. Already I am showing on the diagram. Containing A and B. In a tube of flow. Because liquid flow only, it should be considered. In a tube of flow. A1 and A2 description I covered. V1 and V2 are the speed of fluids. Speed of fluids at A and B. One side is A at the beginning of the tube, and other side of the tube, end of the tube is B. There the speed of the fluid is V1 and V2. Okay na? Now the what nature of the fluid, it is incompressible. Fluid is incompressible. Okay now, entering time at A1 is delta T and leaving time at A2 is delta T. That one I define now. Okay now? Now here I define. Now the liquid entering time at A1 is delta T. A1 is delta T, not visible. Entering time A1 is delta T and leaving time A2 is also same time. What is that? Delta T. Entering time it is delta T and leaving also at the same time. From this, what we are doing now? Equating the value. What we have to equate now? A1 V1 delta T equals to A2 V2 delta T, because entering time and leaving time should be equal for both the sides of the tube. A1 V1 delta T equals to A2 V2. From this now, A1 V1 equals to what you are defining? A2 V2. From this, what you are concluded? We are equating these two. Now delta T is common. A1 V1 equals to A2 V2. Okay now. Now from this, what you are saying now? The product of these two. Product of area of cross section. Area of cross section. Product of area of cross section. Product of area of cross section and speed, because we know and speed remains constant. Speed remains constant. From this, what you are concluded? AV equals to constant. AV equals to constant. From this, A equals to what you got? 1 by V. A equals to what you got? 1 by V. A equals to 1 by V. Now you should draw the diagram for that. Area of cross section along x-axis. Speed is along y-axis. It is decreasing, because these two are inversely proportional. Hence the value is always decreasing. Okay now. Now here the two important conclusions are there. The velocity of the flow from this. Velocity of flow independent of velocity of flow is independent of velocity of flow is independent of the liquid. Independent of the liquid. Independent of the liquid. Velocity of flow is independent of the liquid. Okay. Now, velocity increases, area of cross section decreases. Second point now, velocity increases, not visible, velocity increases, area of cross section decreases. Velocity increases, area of cross section decreases. Area of cross section decreases, because both are inversely proportional. On which applications we are observed this one now? In which applications you are observed? In hill areas, the surface of the water flow, it is not that much of wider. That is very narrow. Whenever the water coming in hill area in a narrow, and it moves at a higher speed, like this in hill area, like this. Here the area of cross section is less, but the water coming from this is higher speed. That means what you have observed the result already. Now A is inversely proportional to B. Already told. In hill area, the surface of this particular flow of water is not wider. Where it becomes narrower, here the area of cross section is less. The water flow speed becomes more at this place. Then A is inversely proportional to B. There indirectly the concept of continuity equation is observed. And similarly, water coming from the tap, water coming from the drop by drop, it should be coming out. And it moves towards the ground. And its velocity is more. Depends upon the area of the cross section. Both are inversely proportional to each other. These two are the main examples relevant to this. Okay now. Now we are observed one of the application for this. We observe now it is the tube. It should be split in two directions like this. One is here and another one this direction. Okay, it is a tube splits like this. Now here named as now area of cross section A1, it is A2. Okay now. Now the liquid at the different values you have to defining now. Velocity is A. Now the point we are defining it is A. Another point is P. One more point is Q. Like this. Okay now. Now the points are here. V and P and Q points are nothing but velocities. Okay now. Like this. It is A1 at point Q, at point P and at point A2. Now the points are here. A1 equals to the given value I have to define A by 2. Now A2 equals to A by 4. Now the value of P, value of splitting one are what? Q and R. They are nothing but the velocities. They define the values are 4 meters per second, 8 meters per second. 4 meters per second, 8 meters per second. Find the velocity at point P. V at point P. V at, because the liquid is coming like this, something is moved like this, another point is in this way. Find the velocity at point P. Now apply the concept of continuity equation. AV equals to, what will come now? A1 V1 plus A2 V2. That means A1 Q plus A2 R. A1 Q plus A2 R. Now what values they are given? You should write accordingly. AV equals to as it is. Now the A1, what value they are given? A1 A by 2. A by 2 into Q value is how much? 4 meters per second. Second one A2 is how much? A by 4. What is the value of R? 8 meters per second. Now AV equals to, that means A value should cancel throughout like this. Then V equals to this value to another 8 by 4 is 2. Then the result is how much? 4 meters per second. That means the speed of the liquid we are finding. The speed of the liquid or the fluid we have to finding with the help of this continuity equation. With the help of continuity equation. Okay. The velocity at point B. What you got now? This one. From this what are concluded? Whenever the area of cross section is narrower, the speed of the liquid becomes small. Because AV is equals to constant, A is inversely proportional to V. That concept described by the continuity equation, the nature of the fluid is incompressible. Okay, now why I am taking this way of presentation, you feel easy. Because myself I have to speak on mobile phone. It is not clear to you. Once I have to explain this on board, then you feel easy to understand what logic behind the, or the what concept behind the continuity equation. I will send immediately this answer what I covered just now. Okay, thank you.